Welcome to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a paper published on April 2nd, 2025, titled LRAGE Legal Retrieval-Augmented Generation Evaluation Tool. This paper introduces an open-source tool called LRAGE, designed to help researchers and developers evaluate Retrieval-Augmented Generation systems, or RAG systems. These RAG systems are a clever way to enhance LLMs by first fetching relevant documents, and then using that information to help the LLM generate more accurate and contextually appropriate responses. What's particularly interesting is its focus on the legal domain, where past decisions, under a principle called stare decisis, heavily influence current ones. LRAGE allows for systematic testing of how various parts of these RAG systems, such as the document collections, or retrieval corpora they search, or specialized components called re-rankers that further refine search results, impact the overall accuracy. And if you want to dive deeper, well, the authors have released the code for this work on GitHub. The repository, also called LRAGE, provides an open-source toolkit to evaluate these legal retrieval-augmented generation pipelines. You'll find the core framework there, along with pre-compiled indexes, which are essentially pre-organized databases for quick searching, and even a graphical user interface demo, which is pretty neat. Alright, so this first figure really helps visualize what LRAGE brings to the table. If you look at the bottom, you see what they call the manual pipeline. This represents the older, more conventional way of evaluating retrieval-augmented generation systems. It's a bit piecemeal, right? You have separate steps like indexing your documents, then retrieving them, merging inputs, pre-processing for evaluation, and finally, the evaluation itself. But with LRAGE, shown at the top as the integrated pipeline, all these different processes are, well, integrated seamlessly into one framework. You feed in your configuration, LRAGE handles the complexities internally, and you get your results. It really streamlines the whole evaluation, which is a big help for researchers. Okay, so building on that idea of an integrated pipeline, Figure 2 gives us a closer look at the actual system diagram of LRAGE, showing how its different parts connect. We see inputs like the corpus, that's the large collection of legal texts it searches, and benchmark datasets, which are used for testing. These feed into modules like the retriever and the re-ranker we discussed, and then to an evaluator. This evaluator can interface with various LLM backbones. What's really highlighted are components like LLM-as-a-Judge, which uses another AI to assess output quality, and, quote, small agents allowing for more complex, agentic RAG where the system can perform multi-step reasoning. So while the previous figure showed us the underlying system architecture, Figure 3 gives us a look at how users actually interact with LRAGE through its Graphical User Interface, or GUI. This GUI makes the whole process much more accessible. You can see it has different tabs like task selection, model settings, generation settings, and then specific settings for document retrieval, including the retriever and re-ranking options we talked about. There's also a tab for LLM-as-a-Judge settings, and finally, a section for results and execution. This layout allows users to easily configure all those components, run their experiments, and then see the outcomes, all in one place. Alright, so after seeing the GUI, Table 2 here gives us some concrete results from the Legal Bench benchmark. It's comparing the accuracy of a retrieval-augmented generation system using different retrieval corpora, those document collections it searches, against a baseline system with no RAG at all. We see results for different legal tasks, like international citizenship questions. For example, using Wikipedia as the corpus boosts accuracy by about 8 percentage points for that task. But for, quote, personal jurisdiction, using a legal dataset called, quote, study materials gives a massive 11-point jump. This really highlights how performance is highly dependent on the specific retrieval corpus chosen. Okay, so following up on the Legal Bench results, Table 1 now shifts focus to the Korean Bar Exam, or KBL benchmark. This table compares different retrieval-augmented generation configurations using two main retrieval corpora, COPs. That's Korean precedents and statutes, so very domain-specific legal texts, and Kowiki, which is Korean Wikipedia. For instance, with the Llama 3.1 to 8b model on the civil subtask. Using COPES generally boosts accuracy over no RAG, especially when paired with a cross-encoder re-ranker, which is a model that reorders retrieved documents for better relevance, giving a 4.3 percentage point increase. In contrast, Koiki often shows less improvement or even hurts performance, highlighting again that domain-specific corpora are crucial. Alright, and continuing our exploration of different legal benchmarks, Table 3 now presents results from LawBench, which focuses on Chinese legal tasks. Here they're comparing Retrieval-Augmented Generation performance using two different retrieval corpora. KALE, that's a Chinese AI and law challenge dataset, so very domain-specific, and ZHWiki, which is Chinese Wikipedia, looking at metrics like accuracy and F1 score, which is a measure that balances both precision, so how many selected items are relevant, and recall, meaning how many relevant items were selected. We see KALE provides a substantial boost, particularly for F1, improving it by 14 points. Again, ZHWiki tends to lower performance, reinforcing that domain-specific data is key. Across these different legal benchmarks, whether it's Legal Bench, the Korean Bar Exam, or Law Bench, the consistent theme is the significant impact of domain-specific retrieval corpora on Retrieval-Augmented Generation performance. The large tool itself is a valuable contribution because it allows researchers and practitioners to systematically evaluate these Retrieval-Augmented Generation systems in the complex legal domain, helping to build more reliable AI for law. Well, that's all for this AI Research Roundup. Thanks for tuning in, and I'm Alex.